Hello, everyone, and welcome to my talk. I will talk about Android lint rule and how you can have cleaner code bases and help your teams. I'm Sinan Kozak. I work at Delivery Hero, and my responsibilities are for mobile foundations and infrastructure of the code base. So basically, we are responsible for creating best practices, helping with migration, and supporting other teams and enabling it. And what does Delivery Hero do is it's a food delivery company, and I'm working in a logistic part, which is responsible for delivering food. So if you don't get any of your deliveries, we are not responsible for that one, hopefully, but we're trying to improve that situation. And let's say during that process, during developing and during enabling other teams, we have lots of learnings and we get lots of experience. But it's really difficult to share those experiences with other team members. We can do trainings, we can have documentation, we can have other kind of practices to distribute the experience, like pair programming. But when the team size gets bigger and the project gets bigger, it's become a pain to share this knowledge. And even when we learn about our mistakes, when we would like to prevent our mistakes, it's become much more difficult because then there might be a couple of gatekeepers in your project that is constantly reminding you not to use certain APIs, or you might constantly get same code reviews, comments from your team members because of misuse of API. And I have a proof, even if the simple APIs might be misused, and I use my dog as the example because from his point of view, it's a perfectly fine usage of the stairs, but that's not how he should climb. And to his defense, he knows how to climb, but he decided to sit on them. So that can happen, all of us, while we're using an API we don't know, and it can even happen with the APIs or the codes that we are familiar of. And there are different solutions for this problem. It's not something new, and it exists from the beginning of the software development. And there are static code analysis to understand the code flow and code usages to prevent the mistakes. And there are also some lints, different languages, to help you format or prevent mistakes again. But if you like to have the extensive list, there's a really nice GitHub repository which lists most of the public static code analysis tools for different languages, and they are some part of the Java and Kotlin. Where if I need to give an example, KT-lint is for formatting, detect for Kotlin specific, sonar is mostly for Java and the Java ecosystem. And why do we have Android lint? Because it helps us to write static code analysis for Android specific resources, like Java files, Kotlin files, layouts, manifest, Gradle, ProGuard property, and list goes on. And recently they added TOML support because Gradle has version control, version catalog with the TOML. And it's now possible to write lint rule for the TOML files as well. And there are also multiple categories where you can also create your own category. When you look at the category, they are not related to each other, but a good thing is there are performance improvements you can get. There are security improvements you can get. It can help you to prevent runtime error or security issues. And that one, I would like to first ask, how many of you are already using Android lint rules integrated with your project? Quite nice. All right, most of you already know the benefit, but for the people who are not using lint rules, I could say that it's a really important flow for your workflow, your work, because it will prevent you lots of unexpected issues in runtime and in the code base as well. One example could be, I will give lots of examples about how it can prevent you and how you can write custom lint rules with a similar mental model. But before going there, I need to tell you that there are lots of existing default lint rules in the Android Gradle plugin and the lint pipeline. So when you enable lint integration and when you start checking lints on your CI builds, you already start getting all of those lints by default. And I would like to show you some of them. For example, they can help you for the target SDK migration. Every target SDK change comes with a different behavior changes. And for those behavior changes, you can go and read the documentation. Sometimes there could be niche migration needs that is not clear with the documentation or wrong usages. And one example for that one is intent filter exported receiver. This only checks for Android 12, if your target SDK Android 12 or higher, and expect you to specifically set export flag for the intents with the filter. If not, if your intents doesn't have export flag, your installation will fail on Android 12. So instead of getting a surprise after releasing, this helps you to find those issues. And the good part is, it can also find issues from the libraries that you included from your dependencies. So this one helped us to release our increase our target SDK until we got all of the necessary dependency updates to prevent any issues that we might get from Android 12. Or there is also trembling notification problem that arises with Android 12. So they decided to prevent any background operation service or broadcast to start an activity from the background. And best practice before that one, using a broadcast receiver for your notification and starting an activity from that notification, from that broadcast listener. But starting from Android 12, operating systems start deprioritizing it. So if you still use that one, it will be slow on Android 12, and it will not work at all at Android 13. So this rule helped us not to get any notification issues. And I could tell you that probably it was WhatsApp or something like that. They had a release where they didn't have any notification working properly. And that was because of probably this one, my wild guess, because there wasn't any incident report. But there are even the big companies are able to get these issues. It also helps you to prevent runtime errors for you. For one example, string format detector. You know that strings XML has lots of capabilities, like adding multiple arguments in the same string, and you can also have plural strings in the layout in the resource XML. And the string formatter detector checks all of the string names in different translation and make sure that all of them has same amount of argument. Because if they don't have the same amount of argument, there will be runtime crashes, because operating system won't know what to do with that missing arguments. It's same with the plural. If one of the translation is plural and the other translation doesn't have that capability, it will also give you the warning. And the other good example is translucent weave detector. Why? Starting from Android O, target SDK Android O, operating system had rules around orientation and start to become much more restrictive. And this rule finds misuse of orientation for the dialog activities. If your activity is floating in dialog, it should have different orientation, which is called behind. It shouldn't set any specific orientation directly. And this helped us to find a couple of issues coming from dependencies again. One of the things that helped me to love lint rules was mutating shared preference. If you get string set from shared preference, it gives you actual instance they read. And if you pass the same instance, same object, even if you mutate it, it will ignore it because it only do a reference check. It doesn't do any equality check. And this was a performance improvement. And there are APIs like isMember class, data flow analyzer, and you can also check method names, and they're using those APIs to understand that if you called a shared preference function and your data flow calls add, remove, or clear functions, they say that, hey, you're mutating an object that I gave to you, and you shouldn't do that one. Instead of saying, hey, they expect you to create a new string set and use that string set and pass it, rather than immediately mutating the objects that is passed. They will preferably fix this kind of issues and operating system gradually, but this kind of data flow analysis might help you to write different lint rules for you. Also, the performance checks. There are lots of knowledge in the community that we know as best practices, like allocation in the draw method. A draw function is called every frame, and if we start allocating paint objects or pads or any other expensive object, our UI will be like, and this is a known phenomenon. And there's a lint rule that checks if we are doing unnecessary initialization or object creation in the draw functions, and prevents that one to happen. Right, before writing your own lint rules, you can use the default ones, but there are also really nice open source libraries from Slack, Uber, and I myself also released. And the Vanitech one is probably the oldest one, which I used. And they all come with really nice lint rules that you can directly use in your company, or since they're open source, learn how they're doing it and alter the way that you like to impose in your own code base. A couple of examples from Vanitech, for example, it has a lint rule that prevents using raw colors in XML and forces you to use colors from the resource file. And that helps you to have much more stable UI and design system, and helps developer to not reinvent the wheel with their new color codes. So you can directly start today by running Lint, and there will be thousands of warnings. It's a good thing. You shouldn't panic about it. Good thing is that you can create baseline file and only care about the lint failures from now on. But my suggestion is, first of all, go over all of the lint warnings that you have got and try to find the important ones, because there might be easy performance gain that you might get. There might be a security issue that you already have. Instead of ignoring them, I highly suggest to focus on the important ones and then create the baseline file. Since you already had the default rules, since you got the rules from the open source, you can create your own lint rule as well. There is a template repo from Google which shows you how to create a submodule in your project where you can write your own lint rule. Good thing is, this Android Lint is not directly about Android. So it uses Android SDK, but the actual mental model and the phenomenal and all of the codes that you're using is about PSI and the actual how compiler understands the code. So you will be using APIs which is similar to how IDE understands the code and how data analysis works, and that will help you to use TDD while writing new rules and focus on what is important rather than new APIs or the lifecycle or any other thing. You can use your own custom lint rules to teach better APIs to your team, prevent calling forbidden APIs. There could be a deprecated function which you would like to prevent anyone calling it, because deprecation annotation is just a visual annotation by itself, but you can also get your own annotations like obsolete or API levels and use those kind of things. This is an example about how you can write tests, and basically you don't even need to create files. You can fake that calling, hey, I will have this Kotlin file in memory, and I would like to run this particular issues. And when you run it, you can expect clean, or you can expect the actual warning that you might get at the end of it. And this is the one happy pad example to just demonstrate. And these files can get Java, resources, layout, XML manifest. So you can basically build a full project over there and run your test on the JVM without requiring an Android devices. Also, since it's a complicated API, ChatGPT also can help you to understand it better, and it can show you how to do it. I simply ask a question, hey, how can I prevent RxJava in our code base, and ask it to do write a lint rule. and it gives some suggestions, then even write some code. This is a cleanup version of it, but the idea is simple. It just looks at the containing class of the method being called and checks if it's a package for RxJava. If it is a package for RxJava, we just say that, hey, this is something that we would like to report, this is something we would like to prevent. But you can also imagine this one using for enforcing your own design system or any other application, any other framework that you have in-house. Some APIs that I would like to show you today, where you can get some inspiration. What you can do is you can ask evaluator if this method inside this class, when you have this information, for example, there could be multiple functions with the same name in the same code base. Only important thing is that if you know that if that function is coming from particular package. With that information, you can prevent and suggest the correct package of that functionality. This can help you about migrating from the legacy APIs that you have or prevent using any unnecessary library functions that you get. You can also write lint rules for the annotations of the classes and methods. Evaluator is able to return all of the annotations, and depending on annotation, you can do multiple things. One example is that when Vanitech repo has RxJava rule to check that if we are using the return of the RxJava call. So imagine that if we have a subscriber, if we have a disposable, if we are not subscribing it, that means nothing happens, nothing is going to happen. And that's a common mistake on RxJava. And that lint rule checks that, hey, this function needs to return something, and somebody needs to use that returned object. If they're not using it, there is clearly a mistake. And they use a get annotation function to understand. There are also a bunch of other APIs in the evaluator, which you can check if it's a companion object, if it is const, or like if it's internal, latent it, and design your rules around that one. When you check the API in the code base, in the lint, besides the evaluator, you can also get the node which is being investigated. And from that node, you can get the method names, how many arguments they have. This is being used for logging libraries that we have, because we would like to pass not just the exception, but also a message with it. So there needs to be at least 2 parameters, and we know by the design, single parameter version of this logging API only gets exceptions, and it doesn't get the string. So we can check that whenever this method called, there needs to be multiple argument. Otherwise, there must be something wrong, and please check. There is also visit class, visit call expression, visit method expression, and a bunch of other helper functions that you can override and use. And that will help you to go over different level of the class and code that you have. You can have a lint rule that starts from the class level, or that can have from the function level, or any other call, or any other parameter. And that gives you much more refined control over what you can do. And how we are using it, if I need to give you some basic usages. For example, we are enforcing having immutable data classes. It's the rule that I shared publicly in the GitHub prevents you to have var definitions or any other list or set, immutable list or set that you can include. And also we have a default, we have our own clickable, which we don't want to use clickable modifier from the compose itself, and we're also planning to prevent that one. Those are like some simple ideas. I'm pretty sure that you will find lots of other good examples, and if you have anything, please share with me. I really thank you for listening to me, and if you have questions, I don't know if you have time, maybe we don't have time, but I will be around if you have any question.